Okay, this video is about graphing rational functions. And this is different than the inverse functions. The inverse function is what we learned first with these graphs, and those have a pattern. It gets repeated each time. And there's different rules about transforming it that we've had with all the other graphs. These rational functions kind of follow, they have the same look and feel of them. They have the asymptotes that are found, but when you graph them, they're not always set up the same way as the last one. So we know how to find the vertical and horizontal asymptotes, but now we can also find the x-intercepts and the y-intercepts. So the x-intercept is found by setting the numerator equal to 0, and the y-intercepts can be found by plugging in 0 for y. Okay, so let's take a look at some examples and see how this is done. So on number 1, and I'll point out to you is that I go through here, I'm going to show my work so you understand where I'm getting the numbers, but a lot of these equations are very simple. And if you can do it in your head, I think it's going to make it much easier for you and not necessary to write every little thing out. Okay, so the first step is the vertical asymptote, and the vertical asymptote is always what makes the denominator 0. So we need to know what would make that 0. So we set x minus 3 equal to 0, so we know it's x equals 3. The horizontal asymptote, well, on these problems, the degree of the top matches the degree of the bottom. So all of these are going to be the ratio of the leading coefficient, which is going to be 2 over 1, which is just 2. So we're going to start by making a vertical line at 3 and a horizontal line at 2. That's the first part, find the asymptotes. The second part is to find the x-intercept. So the x-intercept is what makes the top or the numerator equal to 0. So I'm going to set 2x plus 4 equal to 0. So I get 2x equals negative 4. So x is negative 2. So my x-intercept is negative 2, 0. My y-intercept is when I plug in 0 for the x's right here. Now, if I plug in 0 for those x's, 2 times 0 is just 0. And this is the 0 again here on the bottom. The x's will always go away. And what we're left with is the numbers at the end. And that right there is with a y-intercept. So my y-intercept is going to be 0, negative 4/3. Now, when we go to graph that in a little bit, some of you may struggle with where to plot that. And if you're one of those people that don't understand what that fraction is, you can always use your calculator and do 4 divided by 3, and that's going to give you a decimal, and we get negative 1.3, and that will tell you where to plot it. Okay, so now I go to my graph, and I need to plot these 2 points. So the first point is 0, negative 2, and the next point is, I said that wrong, negative 2, 0, and the next point is 0, negative 4/3, which is over here. Now that I have 2 points, I have the general feel of how that graph is going to look, and I can graph it in, or that section of the graph, I should say. Oh gosh, skipped around. There we go. Okay. I know that when I graph it, it's got to approach the asymptote. So I draw it as a curved arc or kind of a C shape, and it's got to approach the blue lines, but never touch the blue lines. When I do these, just like the inverse graphs, one is going to be in one corner and the other is going to be in the other. So since this graph here, these points are in the bottom left, I know the next set of points have to be up here in the top right. So if I'm trying to figure out what I'm going to do now is plug in these x's and see what the y values are so I can plot them on the graph. Now I can't pick 3 because 3 is an asymptote. So I'm going to start to the right of that at 4. Okay, so the first one I'm going to plug in is 4. So I'm going to write f of 4. F of 4 means I'm going to take this function, which is right here, and I'm going to put in a 4 every time I see an x. So the first part is 2 times 4, which would be 8. So I have 8 plus 4. On the bottom, I have 4 minus 3. So this gives me 12 over 1. So when I plugged in 4, I got 12, and that's the first ordered pair that I'm going to plot. Now, not every point, but a handful of these points are going to be off the graph, and that is okay. I just know 412 is going to be somewhere up here. Good enough. As I work my way to the right, the next, I can't do 3, that's going to the left. My next logical point would be f of 5. So now I'm going to find f of 5. 2 times 5, so that means I'm going to take 5, plug it in for x. 2 times 5 is 10 plus 4. On the bottom, I get 5 minus 3. So that's going to be 14 over 2, which is 7. So at 5, it's at 7, which is on my graph, so that's good. And now I'm going to connect the dots. And when I draw my C in, it needs to be a curved shape, and it needs to be approaching the asymptotes and touching them. All right, let's try the next one. On the next one, the vertical asymptote is always what makes the bottom 0. So I'm going to set 2x plus 6 equal to 0. So I have 2x equals -6. So x is -3. The horizontal asymptote, because the degrees are the same, it's the ratio of the leading coefficients. On these ones you have to graph, it's always going to be the same degree. I'm going to keep it simple for what we're doing and straightforward. So that's going to be 4 over 2, which would just be 2. So now I'm going to have a vertical line at -3, and I'm going to have a horizontal line at 2. Now I need to find the intercepts. The x-intercept is what makes the numerator, the top part of the fraction, 0. So I have 4x minus 1 equals 0. So 4x equals 1. And when I divide by 4, it's 1/4. So it's going to be 1/4, 0. When I find the y-intercept is when the x's are 0. So the x's go away, and it's just this part of the equation gives me the y-intercept. So my y-intercept is going to be 0, -1/6. So after I find those 2 points, I need to plot them on my graph. So 1/4, 0 would be right here. 0, -1/2. Oh, I said 1/6, and then I wrote it too. Okay, 0, -1/6 is right down here. So they're close together, but I can see how the curve is starting to take shape, and they need to be approaching the asymptotes just like so. Now these points are in the bottom right, so I know my other points have to be in the top left. So let's see if we can do that. Now I'm going to find some points to plug in. I can't plug in -3, it's an asymptote. So I'm going to keep working my way to the left. The next one would be -4. So let's plug in -4. So to find f of -4, this notation means plug -4 into the equation. So every time I see an x, I'm going to replace it with a -4. 4 times -4 is -16 minus 1. 2 times -4 is -8 plus 6. So on the top, I get -17, and on the bottom, I get -2. And if I divide that, I get 8.5. So my first point is going to be at -4, 8.5, which is going to be slightly off my graph, and we're okay because we will have points off the graph. Now I'm going to continue to move to the left, because if I go to the right, I'm at my asymptote I can't use, and I know it's in the top left, so I'm going to move over. So now I'm going to go to f of -5. So that's going to be 4 times -5, which is -20 minus 1, over, when I plug in -5, that's going to give me -10 plus 6. So that's -21 over -4. If you don't know how to graph that, make it a decimal in your calculator. 21 divided by 4 is going to be 5.25. That you should know how to graph. It's just past 5. So at -5, it's going to be just past 5, which is here. And then I can go ahead and make my arc. And again, it's a C shape. It's a curve, and it needs to be approaching the asymptotes. All right, let's try this again on number 3. On number 3, the vertical asymptote is where the denominator equals 0. So I'm going to say x minus 2 equals 0. So x equals 2. The horizontal asymptote, because the degree is the same, it's the ratio of the leading coefficients. So it's going to be 1 over 1, which is 1. So now I'm going to graph those 2 lines. So I have a vertical line at x equals 2, and I have a horizontal line at 1. So now I want to find the x-intercept. So the x-intercept is when the numerator, or the top part, equals 0. So when I solve, I get x is -3. So my x-intercept is -3, 0. My y-intercept, remember, is when x goes away, so it's only the numbers at the end, which is going to be 3 over -2. So my y-intercept is 0, -3/2. If you need help, make it a decimal. Do 3 divided by 2 in your calculator. All right, let's plot those 2 points. So we have -3, 0, and 0, -1.5, which is right here. So there is my graph. I have it curved like a C and it is approaching the asymptotes. Since these points in green are in the bottom left, I need to now find more points that are in the top right. Okay, so when I start over here, I can't use 2 because it's the asymptote. My graph can't touch it. So the next logical point would be 3. So now we're going to plug in 3. So I'm going to write f of 3, which means I'm plugging 3 into my equation where I see an x. So I have 3 plus 3 over 3 minus 2. So that gives me 6 over 1. Well, I can plot that. So I'm going to go to 3 and then 6 because I plugged in a 3, which is my x. My answer was 6, which is my y. Now I'm going to keep moving to the right because if I move to the left, I'm on the asymptote, which doesn't work. I need to move to the right. So now I'm going to do f of 4. And if I do f of 4, I'm going to have 4 plus 3 over 4 minus 2, which is going to give me 7 over 2, which if I make a decimal is 3.5. So at 4, it's 3.5. And now I have my second point. When you are doing this, I'm going to require that you have 2 points in each section. And we do. 2 you should be able to find from the intercepts, and then you just have to have 2 more by plugging it in. All right, let's look at number 4. On number 4, the vertical asymptote is what makes the denominator 0. So I'm going to set x plus 1 equal to 0, so x is negative 1. The horizontal asymptote is the ratio of the leading coefficients. So that's going to be 2 over 1, which is just 2. So the first thing I'm going to do is plot my asymptotes. So I have a vertical one at negative 1 and a horizontal line at 2. My x-intercept is when the numerator or the top part equals 0. So I get 2x equals 6, so x is 3. So this is going to be 3, 0. My y-intercept is when x goes away, so it's just going to be the numbers at the end. So it's going to be negative 6 over 1. So I have 0, negative 6. So now I'm going to plot those 3 points. So I have 3, 0, and 0, negative 6. Then I'm going to connect the points, and there's my graph. Because these points ended up in the bottom right, I know my next points have to be in the top left. I know that they can't start at negative 1 because that's on my asymptote. So I'm just going to move over to negative 2. And that's where I'm going to start. So if I put in f of negative 2, that means I'm going to put in a negative 2 everywhere I see the x. 2 times negative 2 is negative 4 minus 6 over negative 2 plus 1. So that's negative 10 over negative 1, which is 10. And we won't freak out when some of them go off the graph. Okay, keep moving to the left. Now I'm going to put in negative 3. 2 times negative 3 is negative 6 minus 6. And then I get negative 3 plus 1. So that gives me negative 12 over negative 2, which is 6. So at negative 3, it's 6. And now I have 2 points at each section. So what I'd like you to do now, if you're still following along, is to pause this video and to try and do 5 on your own. Okay, if you did 5 on your own, the vertical asymptote is where the bottom equals 0. So we get negative 4. Horizontal is the ratio of the coefficients. So it's just 1. The x-intercept is where the top equals 0, which is 2. The y-intercept is the numbers at the end. So it's negative 2 over 4, which is negative 1/2. Those 2 points ended up in the bottom right. So then I needed to look for points in the top left. So I started at negative 5 and got 7. And then I put in negative 6 and got 4. I plotted those 2 points and connected the dots.